Hey everybody, this video today will cover learning target 207, which is nuclear fission. So what is nuclear fission? Well, it's a process that occurs when you have a free neutron all on its own that hits a nucleus of an unstable atom at high speeds. And what will actually happen is this neutron causes that nucleus to become so unstable that the atom will actually split, producing two new particles, two new elements that are radioactive. Sometimes it'll produce three, but that's a really rare occurrence. So it's usually two new elements. It'll also produce two more neutrons, and then also release quite a bit of energy. And then what happens is these two neutrons go on and actually strike even more nuclei, unstable nuclei of the particles around it, causing those to split. And so what you have is what's called either a cascade or a chain reaction. And what that means is that this neutron first starts the reaction with this one plutonium atom, for example, where it splits and produces two more neutrons that go on and split even more plutonium atoms that they themselves release neutrons. And so you have a self-sustaining reaction that increases in magnitude as time progresses. And how that ties into everything we've been learning, it's actually a big application of that equation E equals mc squared that Einstein was able to discover. And what that equation helps you do is find the amount of energy that's released through this reaction. And it's actually a really big application, nuclear fission, of kind of the nuclear physics early on, when they really got that jump from Einstein in his work. And this was some of their biggest applications of it so far. And now, so at the bottom of the slide here, I've got a reaction right here. You have a plutonium-239 atom that's hit with a neutron. It releases two neutrons, two new elements, and then energy. And then I also have this same equation here that's in this animation, kind of showing the same process. And there you have the neutron that hits it, you have the two elements that are released, you have energy, and then the two neutrons, which, like I said, will go on and hit other plutonium atoms, causing the same thing to happen. Now, what are some examples of fission reactions? Well, you have, obviously, atom bombs are a big one. And how those work is they're designed to release a lot of energy really fast. And so what they try to do is get as much of their sample of plutonium or uranium to go through this fission reaction quickly, so that it releases all this energy in a really short amount of time, making a powerful blast. Nuclear reactors, on the other hand, they do the same fission process, but they do it much more slowly, where they want to release their energy over a longer period of time so that we can actually harness it. And like we would heat in a lot of instances, they heat water with it, with that energy that produces heat, and that heats up the water, turns it into steam, which then powers turbines that generate electricity. And another interesting example of a fission reaction that I found was a naturally occurring reaction, like a nuclear reactor made by nature in Africa. And scientists believe it happened about 2 billion years ago. And the way they discovered this was that they were digging in a uranium mine in Africa, and the uranium coming out of that mine had a lower concentration than most other uranium mines around the world. And when they compared that uranium out of this mine to uranium that came out of a nuclear reactor after it was spent and used in the nuclear fission reaction, the concentration of uranium was very similar in both samples. And so what they hypothesized was that there must have been, about 2 billion years ago, this nuclear fission reaction that occurred in the ground all by itself, that then left this sample of uranium that had gone through fission and resembled that coming out of nuclear power plants. But yeah, I think that's all for nuclear fission. I hope this video helps, and thanks for watching.